Okay, folks, 64th installment, we're going to talk about graphing quadratic functions from the standard form of the equation. And then from that, once we have a graph, we want to be able to figure out what the domain and range are of what's going on here. Let's get started. Okay. So here's our first example. Let's talk about the domain first. So we're just going to go from the graph. So the domain, if you remember from grade 10, is all the values of x that you're allowed to have. And on a graph of a parabola, unless there's a contextual issue, so you're doing a word problem where certain values wouldn't make any sense or something like that, there's no restriction to how far left or right you can go. So your domain is pretty simple. Any value at all of x is going to do the job for you. Okay, so we say x can be anything, any real number like that, same way you wrote them in grade 10. And then when we talk about the interval notation, we say it can be any number from negative infinity all the way on to positive infinity. And round brackets, remember, because infinity is not really a number. So that's going to be the same for both of these, okay? So that's the same domain for both functions. When it comes to their ranges, however, we're going to have to trim that down a little bit. So let's look at the range of both of these guys. For the first one, remember, it's all values of y that are real, except for any that we're never actually going to get to and touch. So are there any values of y that we're not going to touch on the first graph? Sure. The lowest we ever get on the graph is -3, so we can say that y is any number that's greater than or equal to -3. Okay? And so for the other one, it's something similar. Any real number, as long as y is, in this case, we never get above 4, so y is any number that's less than or equal to 4. Okay? So there's the range, and then let's write those in interval notation. So for the first one, range is bottom to top, so we can go from -3, square bracket, because we're allowed to get to that vertex, all the way to infinity, which we never touch. And for the second one, we're going to go from negative infinity at the very bottom all the way up to +4, square bracket, because we get to the vertex. Okay? Now let's talk about how we actually sketch the graph of a quadratic from its standard form, and then from that, we'll write the domain and range for that graph. Okay? So a couple of things that are important if you want to sketch a graph of a quadratic. So far, a couple of key points that we're able to find are the vertex and the y-intercept. And if we can find both of those, we'll be able to make a reasonable sketch. So the x-coordinate of our vertex shows up wherever the axis of symmetry is, and that's at x equals -b over 2a. Remember that formula that we have. So we've got negative of -6 over 2 times 1. So that's going to be 6 over 2, which is a 3. So our x-coordinate for our vertex is going to be at 3. And to get the y-coordinate, we fill that number back into our equation and then calculate what y would have to be equal to. So this is going to be 9 minus 18 plus 7, which I think comes out to be about -2. Whoops, that's not a 2. Now it is. So we've got a y-coordinate for our vertex at -2. Okay? We're going to note that our parabola opens upward, and the y-intercept we get from the value of c, that's going to be at 0 and 7. Okay? Another way to check on that y-intercept is if you let x equal 0, plug it into both of these for 0, then you get 0 minus 0 plus 7 is just 7. Okay? Now to draw this graph, let's see if we can put some numbers on this thing. I'm going to go 5 units left and right to start with, and 5 units up and down. The old rule of 5 to get started. And then we'll break those into 4 little divisions. So 1, 2, 3, 4. 1, 2, 3, and 4, something like that. Just rough-handing a graph here. Freehanding, rough-handing, whatever we're going to call it today. Go a couple extra for each one. Go 3 extra on top because I know I'm going to need another one for that 7. Okay. So the vertex we found here was at +3 and -2. So over 3 units and down 2 units, and that puts us right about there. And we have a y-intercept at +7 up here. And then I'm going to imagine my axis of symmetry coming down through my vertex. And of course, that would be at x equals 3. You don't have to draw the axis of symmetry to draw a parabola, but it's a nice thing to help you draw the graph. And of course, we're going to be symmetric about that axis of symmetry on both sides and make sure that we run right through that y-intercept like that. Okay? So let's scribble in these coordinates. 3, -2. So the -2 now becomes the most important thing for us when we go to write our domain and range. The domain of this function is going to start at -infinity and go all the way to +infinity like it does for all parabolas. Or if you wanted to write it in set notation, it's a set of all values of x that are real, as long as, well, no restrictions at all, so as long as nothing. Okay, so there's our domain, same for all parabolas that are without a context. And then we'll find our range. So let's write down the range for this guy. And if we write that in interval notation, I don't know which notation you prefer. My students always seem to like the interval notation better. It's easier to write. So we're going to go from -2 on the bottom all the way up to positive infinity on the top of this one. So from -2 all the way up to infinity. So basically what that means, if we write that in set notation, is we have all values of y that are real, as long as y is any number that's greater than or equal to -2. And that's it. That's your domain and range. Okay, so if you want to sketch the graph, we all know how to find a vertex. So do that, then find the y-intercept. Sketch your axis of symmetry right through the middle there. That's a big deal. So get that axis of symmetry going, and then use the symmetry with the y-intercept, and then you can make your graph go through there. Nice parabola. All right. So a quick rundown of all the things we talked about here. So determine the axis of symmetry and the coordinates of the vertex. Find the y-intercept and the direction of opening. Now, once you know your y-intercept, you can see the direction of opening anyway, but it's a good way to check to make sure that you're consistent. And then we use symmetry to sketch that graph. And from the graph, we should be able to state the domain and range. So the domain is the same for all parabolas, looks like this, unless, of course, there's a contextual problem where we have to put some other restrictions on it. But for what we're doing now, that's not the case. Now, the range is different. If the graph opens up, we go from wherever the bottom of the graph is, so the minimum value at that vertex, all the way up to infinity, and we include, square bracket for include, the vertex. Or we say that x has to be greater than or equal to, oh, that should say y, shouldn't it? Y. Typo, typo, typo. These should all be y's. Y's for ranges. You would think somebody who didn't know what they were doing wrote this. I'm not really sure who did it. I'm making excuses now. In any event, so then if our graph opens downward, we can say that y has to go from -infinity up to the vertex, or it's any number that's less than or equal to it. And that's about it. Okay, good luck. See you next time.